Hi, I am Dr. Musimbi of the Ethics Department, Colorado School of Mines, and I'll go over some computation methods of the optimal lot size that we'll use in our fall 2014 project. So let's start with some of the questions that we have regarding this problem. Well, the first question that comes to mind is, what is the optimal size of the lot that we have to choose for our project? Are we going to go with a single-story building or a double-story building? For simplicity, we will assume rectangular shapes. This is a representation of the lot that we have. It's 150 by 200 square feet lot. So the question we have is, are we using the whole lot or are we using a portion of it? Can go from a full lot all the way down to, let's say, half of the lot. What is the optimal size that we have to go with? These are the questions that we have with this project. We'll start our computation with defining some parameters that we'll need. First parameter we'll define is the distance d, which is the distance from the far left of the lot to the optimal width that we'll determine. So the optimal width that we'll determine will be the full width of the lot, 150, minus d, and then we'll obtain the actual width of the lot that we're looking for. D will be that distance from the far left to the optimal width. S will be the setback of the code. This is defined by the building code, and we'll define a quantity A min as the minimum building area as defined by the code. So D will be the distance from the far left of the lot to where we're stopping to define our optimal width. So we'll define this distance here, which is an unknown, as D, meaning the optimal width of our lot will be the remaining distance from here to here. After we define our distance D, we'll then introduce the distances from the border of the lot to where we're actually starting our constructions. So we'll define those as S. So the area we have left is the length outside minus twice the setbacks multiplied by the optimal width minus twice the setbacks. The length of our side minus twice the setbacks multiplied by the optimal width minus twice the setbacks. So we'll do some math and then find a way to compute our distance D to obtain optimal width. Well, this is the formula that we will find after we do some math. And then we'll start substituting some numerical value. We'll assume setbacks of 20 feet and a minimum area of in terms of square footage of 14,700 square feet for the single story. So plugging back these numbers in the formula, we determine that D is equal to 18 feet. And with this distance of 18 feet being less than 25 feet, we'll choose a 100 by 200 square foot size lot. So this is the entire lot. So the distance D that we just determined is less than 25, so it will fall here in between. That's why we're choosing the entire lot. Now, if we want to put the structure on two stories, we'll divide the minimum area by 2. So the minimum area will be 14,700 divided by 2 would be 7,350 square foot for each story. And then the new distance D that we'll compute with this new minimum area will be 92 feet. So 92 feet would be the distance from here to here. We'll select a lot of 100 by 200 square feet, which is a minimal lot size. So in terms of recommendation, We can go with the full lot size, 150 by 200 square feet for a single story building, or we can choose a much smaller lot size of 100 by 200 square feet for a two-story building and help MLI save some money. Thank you very much.